slide shares. Hello, I welcome to you to the Agrihub INSPIRE Hackathon presentation for challenge number 2. It's called Analytical Tools for Whiteboard. It was mentored by Runar Bergheim, and in the team we are 5 people. Let's start with the problem. With an increasing trend towards database decision-making, both on governmental and operational levels, the ability to effectively communicate through maps is increasingly important. Here we can see a picture of the pre-COVID era, where the planning process is being done on a physical map in the same room, many people. You can see it's very dangerous. So we wanted to improve this process, and the idea of MapWhiteBoard was born. We aim to make a tool similar to Google Docs, but for maps, for spatial data. This tool would allow people to cooperate on a map surface in the web browser. Doesn't matter if they are in the same network or just somewhere in the internet. They would be able to create new spatial layers, add data to them, draw features together on a shared layer, edit their attributes, and see each other's cursor and what edits everybody has made. So the concept is quite simple. And we found out that there don't exist many tools in the internet which does this. A little bit from the history, the idea was actually born quite a long time ago in INSPIRE Hackathon in 2016. And a really quick proof of concept application was developed. Back in those days, the hackathons were just a couple of days or a couple of hours instead of a couple of months. So later on, it was quite heavily reworked. And the concept was also presented in the OGC Joint Workshop Series, Maps for Web, in 2020. And yeah, the concept of map synchronization was introduced in the workshop. During the INSPIRE Hackathon 2020, the first version of MapWhiteBoard was developed. A library was created and also a server component. And later on in 2021, a dashboard application was developed where users could create new compositions. The authentication registration part was being made, and it was an administrative interface was created for managing these compositions, and so the users would be able to join and use this tool as it was intended in the beginning. In the Open Spring INSPIRE Hackathon in 2021, also new business models were started to be discussed, and this process has led to this year's hackathon, where we wanted to polish this tool and create new use cases, or at least discuss them and see which ones would be more viable in the future. In this year's hackathon, we focus on the authentication processes and the stability of the MapWhiteBoard system. Talking about business use cases, we identified 3 possible directions where we would like to take this tool. The first one was collaborative analysis for smart farming. So we would like to make this tool more focused on the farming and not be so general. And another use case would be a general integrated spatial planning tool. And the third one is meeting augmentation tool similar to Miro or Miro. I will talk a little bit more in detail about each of these three. So the collaborative analysis for smart farming, the MapWhiteBoard would be then used as an add-on to an existing application or another window, as to say, and this would help to perform automatical zoning of agricultural fields based on remote sensing data. The application would take as an input satellite imagery time series data, calculate indices such as NDVI and other vegetation indexes, and the resulting 4D data would be used to determine zones in the respective field. And that should be treated differently with respect to fertilization, irrigation, pesticide application, etc. And MapWhiteBoard would then be used as a data augmentation tool to help these machine learning algorithms with the classification task by annotating the data and extracting features, or just in simple words, the user would, with his human eye, would see some zones in the fields where the processes need to be different from other zones, and then would click on these places in those fields, and that would help the algorithm to divide the larger field into zones. The result would look like something like this. This is another application which runs on the same tool stack as MapWhiteBoard does, namely Aegis Layers NG. And on the left image you can see a field where the layer of NDVI index is displayed in the map, and on this very colorful image on the right side of this split map image, you can see the already classified fields based on different management zones. So the differences between the fields are more visible, and also they can be used in the tractors or other machinery to apply fertilizer in different doses or do some other different tasks. And on the right side image you can see one possible use case where the fields might be divided into zones based on sensor readings. Here, for example, you can see air humidity sensor readings from a large network of sensors, which are evenly distributed in the fields. Yeah, you can see that the humidity isn't homogeneous in all the field, but it differs quite much. And this kind of map layer is dynamically generated on the fly as the sensor readings come into the sensor system. And with MapWhiteBoard, it could also be collaboratively edited, and management zones can be edited and created by on demand. So another use case which we explored was the integrated spatial planning tool, where MapWhiteBoard is used as a component supporting collaborative planning processes, which have been quite popular recently in many different industries or fields, from business industry, real estate, different NGOs and civil society organizations, and quite recently during the military conflict in Ukraine, these kind of tools have also been used in the military. Yeah, we might still need some work to be done if we want to target the military, but that's also one possible direction where we can work. So another avenue which we explored is a more generic meeting augmentation tool, inspired by tools such as Menti or Miro, which provide polling functions and are used as an add-on for different conferences. And but these tools usually focus on the whiteboard, but not on the map part. So they are not spatial data related or aligned. So we would, with MapWhiteBoard, we would bring something new to the table and enable shared map to allow users to cooperate, draw on the map, and then export the end result to some spatial format which can be used in GIS software. For example, to export it to GeoPackage, shapefiles, GeoJSONs, or directly export them to map services such as WMS with the help of Layman. It's another tool we have developed. Other colleagues of us have developed in the Plan for All organization. So this was the more thematic strand, and now we come to the technical strand. So in the discussion on the beginning of the hackathon, we identified several directions or issues which we would like to solve during the hackathon. Here is the list of these issues. So it's an ongoing process. So we still are documenting the API, both for WebSockets and for REST API, such as managing layers, sessions, users, etc. And a large task was to support multiple authentication options, such as OAuth 2, basic auth, and token-based authentication methods to increase the scalability of the system and make it suitable for different use cases. Also, an ongoing effort is on the stability and error tolerance front. We have to, or we solved different issues dealing with reconnection and such things. Also, race conditions between the edits of features. If users edit the same feature at the same time, how to solve that? We still plan to create a more generic plugin or extend the MapWhiteBoard library code because currently the whole system runs in three. It's split into three parts. There is the MapWhite library, and so it's a general small footprint library. Then there is this admin or dashboard interface, which is like a wrapper around this library, which actually provides what you see in the screen on the screen, because without the interface, the MapWhiteBoard library just focuses on the real-time communication between the map clients. And also an ongoing part is document the installation and deployment process in different operating systems. And also, if you would like to farmers or other users to use our tool, we need to a little bit focus on the user ergonomics part, so support multiple kinds of devices, not only computer monitors and mouses, but also tablets, phones, etc. During the beginning of the hackathon, a landing page was created, so users would not be intimidated by the interface right from the beginning. And we can see the result here. It also contains a more extensive video which covers the process of creating these collaborative maps, but it's 4 minutes long, and it would not fit in this presentation. It was also made in another hackathon, the previous INSPIRE hackathon. But here in the MapWhiteBoard landing page, you can read why it's useful and how to collaborate and yeah. So just to get the general overview of MapWhiteBoard. Also on the technical strand, as I mentioned, was improvement of authentication methods. We are now supporting logging in with Facebook and Google. In theory, also other social sign-in providers could be supported, but currently we have stuck with those two, and we plan to also use a general vectail or liferay based authentication to link together the different parts of softwares, server and client-side softwares which are developed inside Plan for All. And on the right screen, you can see the end result of the work where we extended the authentication methods which might be used by the MapWhiteBoard server interface or server-side component. Previously, it was only the session-based authentication, but currently we came to the conclusion that it's good to use JSON Web Tokens to increase the scalability of this whole system. So the session data would be stored at the client side and encrypted. So it would be sent to the server on each request, but it's generally considered to be a better scalable approach if we want to move to thousands or millions of users. And to make the system more easily used in different automation processes or clients based on different tool stacks might be connect to the MapWhiteBoard request map layers, add something to the maps, either through scripting or through other means. We also must support basic authentication, because sometimes the storing of these JWT or session ID data is not possible. Another topic we explored was how to support these different directions where the MapWhiteBoard development might take us, how to at the same time support spatial planners, farmers, general meeting organizers, and yeah, all these use cases in one interface. And we came to the conclusion that we need to introduce something called apps, or maybe widgets, where the functionality is grouped by topic. So here in this screen you can see how two apps might be added to the map. The user might simply click plus button and then choose one app. We developed two applications, sub-applications of the whiteboard. One is statistics tool, where the user can upload CSV files, do some correlation, and see how different statistical variables are linked together, and then display this data spatially on a map. And the other app is completely different. It focuses on exploring different agroclimatic factors. So basically to help the farmer to see what's going on his field. What has been the temperature in different times of year, how the plants grow, how the field might be divided into management zones, etc. And the technology enabling this is quite promising. It's called micro frontends or module federation. It has been available to Angular based applications just recently, since last year, May. And this allows us to compile different standalone applications, but also provide a module, provide them as a module which might be integrated or easily loaded into different container applications. So MapWhiteBoard in this example, we might load all the applications which are based on Aegis layers or Angular into MapWhiteBoard applications, as long as they support the same API, or the API hasn't diverged too much. So this was quite successfully proof tested, and we created 2 pilots. So just to conclude the presentation, I will quickly go through the findings and conclusions. So the work on MapWhiteBoard still continues. It's taking shape. Various improvements in the authentication and robustness have been made. We have identified several use cases where the system might be used, but we still are seeking for users with real-world problems where MapWhiteBoard might come as a solution. And as I mentioned previous slide, we explored ways how the functionality can be separated into apps and loaded into MapWhiteBoard as a micro frontend. So thank you. That was our presentation about MapWhiteBoard, and yeah, that's it. Thank you.